10 minutes also. Then I will close the session. One second, I will put a okay. Guys, this is called a packet tracer. It's from Cisco. Cisco is one of the leading networking technology company. Okay, Cisco is a company which is providing networking related solutions like switches, routers, firewalls. Okay, so VPNs, right? So different networking related solutions from Cisco. The headquarters is San Jose, California. Okay. So current CEO is still Czech Robbins from 2015. Okay. And Cisco is a company which is providing networking, mainly networking related solutions, security related solutions, data center related solutions by Cisco company. Okay. And this Cisco also providing different kind of curriculums to learn people to teach different kind of networking related, okay, like a Cisco routers, switches configurations, like that. So they are providing a curriculum, means like a academics kind of stuff. Okay, you can learn and do certification of Cisco. Means once you join an organization, any organization, once you join it, so you are keep learning. If you are interested in a networking related domain, so you can do the Cisco related Cisco CCNA certification. Then it is give more opportunities in a networking related jobs. Network administrator, network engineers, okay, security engineers. So many things are there inside. Skills for all and NetAcad. There is a two websites. Means both are for Cisco related only. The Skills for all and NetAcad. So why it is not open? I will directly open from here. Skills for all. Still not open. Still not showing that one. Showing Python Institute. Okay. Learn. Training. So many things is done. No. Go to skillsforall.com like this. It will take you to the another site called netacad.com. So netacad.com is since starting onwards, netacad only. So Cisco wantedly separated for free courses, skills for all. Okay. Now they are merged together again. So you can go use skills for all or a netacad. So then it will open the netacad only. It providing just different kind of curriculums, guys. You can see if you want to learn about cyber security, introduction to cyber security, some courses are free and some are paid one. Free one you can learn, paid one you can't learn directly from this site. Okay, so paid one means from academy partners you can able to learn it. Okay, some are free courses, some are not free courses. These are all. Most of them are free courses. See, Introduction to Cyber Security, Ethical Hackers, Cyber Security Essentials. If you open, you can see it's a beginner, but somewhere it is right, free course, free like that. It's not a free one. So find an academy means it's not a free one. If you see Introduction to Cyber Security, it is showing free. It will shows get started with the self-paced. Okay, it means you can learn yourself. It's a free one, self-placed course. No need to pay. Just you need to log in and started learning any free one. Networking essentials, networking basics. Online gets self-placed. free 22 hours beginners level and 13 labs included in this curriculum. Okay. So like that, so modern AI. So this is a new one, introduction to modern AI, data science. Okay. AI fundamentals with this one, Python essentials, C language, C++ essentials, operating system basics, hardware basics, IT essentials. So different courses are available. Some are paid, some are free. Even this is also more helpful to improve your communication skills and IT related communication skills. Okay. Different things are there, like cyber security, networking related, data science, programming. So you can choose any course, this like a language wise, okay, certification wise also. You can also do two different certifications. One is cyber security technician, junior cyber security technician, networking related. These two are, you can directly learn full course from it. You want to do this certification, cyber security, and these are the courses covers in this curriculum. So they are giving the entire core curriculum part. They are not giving. Okay. This is the details of only details only there. But start today means it will give you that curriculum. It is asking for login, so it will take a login, and if once you login, you can able to access it. Okay. You can create your own account. So whenever you like, just create your own account. So you can log in and start learning anything from it, including Linux is also possible. You can learn it, JavaScript like that also you can learn it from it. So when you click on login, so it will ask for the sign up. Click on the sign up, your country, state, date of birth, month of birth. So compulsory 18 years and above is required. Once you give in, continue, give your email ID, like the details, strong password you have to give. And what I'm trying to say is, so this is also a simulation software from Cisco for learning networking, designing networking purpose, testing networking related. So we can use this simulation software. So understand guys, both. Only 14. Yeah. Okay. So anyway, so whatever I open this Cisco packet tracer to show some of the things, how it is look like, how to connect it, and how it is work. So that purpose I opened this thing. Okay. Mainly to hub and switches purpose. Just I'm going back once to this list. So we discussed about NICs. What is NIC? Network interface card. To connect any device to the network, we need an NIC. Whether it is wide type of connectivity or wireless type of connectivity. For wide type of connectivity, generally we use Ethernet cards or LAN cards we are using. Okay. But mostly built inside your devices, or you can use additional adapter to connect wirelessly. Okay. Every NIC having MAC address. So MAC address is given by this, the device NIC's manufacturer on. Next one we discussed about a media, different types of connectivities, cables, media. Okay. So media in a wireless type of connectivity or wide type of connectivity. In wide type of connectivity means, so there is a cables requirement. Generally, coaxial cable, twisted pair cable means UTP or STP cable. Next one is fiber optical cables. Okay. Wireless media through wireless like 2.4 gigahertz wireless means 2.4 gigahertz band we are connecting, and 5 gigahertz band-wise we are connecting. Okay, wireless type of connectivities. Next one is, of course, as is any diagram as it is, right? So we need an NIC, we need some media to connect, right? So where you will connect? Where you will connect? You have to connect it to a device. So then only we can able to communicate, right? We may connect it to another computer, or maybe you are connecting via hub or a switch, like that, right? You will connect to the device. So what are these devices? What are these devices? Okay. So that's what we are going to discuss today. Yeah, tell me. Someone is trying. Yeah, we discussed about the cables. Now we'll see the networking devices first. First one is hub, repeater, switches, bridges, routers, modems. Somewhat you can use the firewalls. If possible, I will explain the firewalls also. Otherwise, I will give some information. Okay. So the highlighted one is compulsory. You should know it. Hubs, switches, routers, and modems. Compulsory. You must know what it is. Okay. Compulsories. Of course, firewall is one of the also one of the important thing right now. Okay. I'm adding this extra wireless access point, which we have already seen these things. Wi-Fi routers. Okay. So important one, all these things are very important one, of course. But hubs, switches, routers, modem. These four are we are going to discuss from. Hub is used in a LAN communication. Okay, I just only highlighted point I will tell, then I will explain the complete details. Okay. Hub is used for LAN communication, small networks, to create a simple LAN communication with a small number of devices. Small network means number of devices in network is smaller number, 4 computers, 5 computers, like that. That is hub. Repeater. Repeater. Okay, what is this repeater? Repeater, repeat the signal. Repeater, repeat the signal to communicate longer distances. As I said, UTP, STP cables having a limited distance communication, like a 100 meters only, it can maximum 100 meters you can communicate. For example, your the destination device means your device, the next cable, other end of the device is more than 100 meters. So you can't communicate. So, right. So what you will do? you will put a one repeater in between. So for long distance communication, we need a repeater. Switches. Hubs and switches both are used for LAN communication only. But switch also used for both small and large size of networks. Means more number of devices, not only 5, 10 devices. Also you can use 20, 30, 40, like a more number of devices you can use to connect in the network. The useful, like more number of devices you can connect it. And switch is also having a MAC learning kind of stuff. MAC learning, MAC address table, this kind of stuff. Again, bridge. Bridge is not actually physical bridge. Okay, it is software based. It's a bridge between two networks or two NICs bridging. Simple example to understand bridging is Wi-Fi hotspot. Okay, Wi-Fi hotspot. What is Wi-Fi hotspot? You are connected to 4G network. Your mobile is connected to 4G or 5G. You are connected. So you're receiving data connecting to 4G mobile network. And you are sharing that network to other devices, to your laptop or any other mobile phones using Wi-Fi hotspot. So your 4G is one kind of network, one kind of NIC, one kind of network. Your hotspot, that's a Wi-Fi hotspot, means it's a Wi-Fi related kind of stuff, right? Separate devices, which is inside your mobile phone. Okay. So you are bridging between them. So then I can able to access internet from your Wi-Fi hotspot. Actual Wi-Fi hotspot is bridge to your 4G. Through 4G I can able to access. Okay. So that is called a bridging. In a servers also we use that bridge connectivity between two different networks, two NICs for forwarding packets to another network like that. Okay. And another important one is a router. Router used in both LAN and WAN communications. LAN you can use it router, and as well as the WAN places also you can use it. Okay. LAN local area networks, you can use a router. Also, where is the wide area networks, like you are communicating to youtube.com, facebook.com, somewhere it is located. In between your system to or your mobile phone or your system to the destination. So there is a lot of routers in the internet. Okay, they are connected each other. They will give you a path to reach the destination. And router is also, you can call it as a inter-networking device. Inter-networking device. So it shows best path to reach the destination. Inter-networking device. And router also shows best path to reach the destination. Okay. Best path to reach the destination. Modem. Modem, already we discussed about modem, right? Modem is a device used to connect your network to internet. Okay, modem used to connect our network to internet via ISP. So first it will connect it to ISP. Through ISP you can able to access internet. Okay, with a dedicated bandwidth. Okay, there is some bandwidth. So how you will can able to connect? Using telephone cables, fiber optical cables. Okay. And also we discussed about actually a wireless access point to connect wireless devices. Wi-Fi router is all-in-one for all the devices inside of your Wi-Fi router. Firewall is used for protect your network. It won't allow any unauthorized access using IP address or network address or protocols or port numbers or application wide also. It will verify is it allowed, then it will allow it, not allowed, not allowed, like a security guard. Okay. It's a firewall device. Okay, guys, about your devices, simple point, right? So I will take attendance in 5 minutes. Then why people are not responding? Nothing. Don't understand.
Yeah.
Okay. Speaker. Okay, we'll see. Hub. First device is hub. Hub is a non-intelligent. Non-intelligent means it does not process anything. Like you don't understand any MAC address of your packet or IP address of your packet. Okay, or content in the packet also. Okay, so it just forward the packet to other ports. Okay. Hub is used in LAN communication. Key points, guys, remember. So hub is used for LAN communication. Suitable for small networks. Why it is suitable for small, we'll see. Okay. And this is a OSA model. In a OSA model, there is 7 layers are there. An example for a layer 1 device is our hub. Okay. So there is 7 layers. So seventh means the first layer, we call it as a physical layer. Example for that one is this hub. Okay. And a very important point about hub is, another important one is, it broadcasts the packets to every device in the network. It broadcasts packets to every device in the network. So what is that meaning? I have a systems are connected to the hub through hub. Okay. For example, this is A, B, C, D, and EPC. Now A want to send a packet to B, some communication. Maybe it's a ping related, or maybe it is sending some data or chat message, whatever it is. Okay. The data is sent to the hub. Data will going to send to the hub. Okay. This port where it is connected port, hub port. Then what is this hub is doing is, hub send this data to every device is, which is all devices are connected with those, sorry, every device connected to the hub. Okay, it's sent to everyone. Simply say it's sent to everyone. So that is what we call it as a broadcast. Okay, so packet is from A to the hub port. From this one, it is broadcast packet to everyone. The original destination is B, but it's sent to B and as well as C, as well as D and as E also. It's sent to everyone, broadcasting. So B accept the packet, remaining drop the packet. Remaining are drop the packet. So this is called a broadcasting. This is how hub is works. Understand, guys?
Yes, sir.
Very good. Good. At least one response. Similar time in case A is sending packet to B, same time B is sending packet to something like a D, and same time D is sending packet to E. So what happened? B is sending, so B send packet to D, but actually packet sent to A as well as C as well as D as well as E. C send a packet to E, so that it's sent to the B, packet is sent to A as well as D as well as E. So what happened here? The E is receiving a packet from A and from B, from C also. Actually, that C to E only exact destination. That packet only original packet. Remaining are not belongs to the E. So what happened? When it is receive the packet, check the IP address. So from and to address, right? It's not a E's address. Then it will drop the packet. We check the destination address and drop the packet. It is its packet, it will accept it. See what happened here? More traffic is generating. So for A, it is receiving B's packet and C's packet, but nothing. A is not required to receive any packet right now. Nothing is for A's packet. Okay, not two address is not A is not here, right? So to B is there, to D is there, to E is there, but not A. But A is receiving all the packets. So sometimes it compromises security, but generally it's possible like security. Second one is more broadcasting. Entire packets always broadcast. What happened? More traffic generated, more packets means so the packet what happened? It collide each other. It's, the packet traveling means it's a electrical signal, so it's mixer, and then packet collision is occurs. Packet data loss. Packet data loss. When our destination received a corrupted packet, again source will send again extra traffic. Okay, so that is your hub. That's why I said hub is suitable for small networks. Hub is suitable for small networks. Okay, so hub broadcasts the packets to every device in the network. Always broadcast. Okay? This is the device how it is. Hub is look like. Okay, A send a packet to B. A send a packet to B, but A send to hub to all other devices. B accept the packet, remaining drop the packet. So number of collisions occurs because of this. More packets are sending and receiving, even there is not meant for that destination. Okay, so then data loss occurs with this hub. That's it is suitable for small, not for a larger the network. And hub is layered one device, physical layer, because in physical layer there is no MAC address and IP address kind of stuff. This is one kind of hub. Okay, already I showed one hub there. That is how actually hub is look like. This is Cisco packet tracers hub. So this is a small box and power on or off. There is a plug points. It means our RJ45 connecting points. Okay, this is configuration. Nothing you can able to change the name. Nothing to configure in hub. Okay, you can connect so multiple devices to it, just like click here and you will get PCs. Just to understanding purpose only, not to show any specific practically. So I'm connecting to this hub. So I'm connecting from my PC, an IC card, you can see. So there is a LAN port, okay, Ethernet port. And here also we have a Ethernet ports. So what I'm doing is I'm connecting from here to see Ethernet 1, 2, 3, 4 like this ports. Here also the lot of things you have to connect from our system Ethernet to here Ethernet. Okay. So I created a network, but I try to communicate. To communicate, we need an IP address first of all. So I'm assigning some IP address to here manually. Okay. See, this simulation helps you to understand how it is works. Initially, I'm sending packet from here to here. My communication, yes, successful. You can see successful communication here. Now simulation, how the packet is traveling it here from here to here, for example. Okay. So this is saying what is source, then what is destination for IP address. The first step is first packet sent to the hub. Packet sent to the hub. If you see, packet came to the 0 and sent to 1, 2, 3. But original destination is third one, this one only. So it is sent to everyone. These two are drop the packet. This is accept the packet. Again, it is replying the packet sent to the hub. Again, it is sent to the every other devices. Others are drop the packet, and this is accept the packet. Again, I'm running. First time or next time or every time. This always broadcast the package. Okay. So hub never don't know which device, where it is located, where it is connected. It does not recognize any device. This is how hubs works. Broadcasting packets to every device in the net. Does understand hub?
Yes,
Yes,
sir.
sir.
Yes, sir.
Good, good. Sorry. Repeater. So we'll discuss switch, but before that one there is a repeater. So once we see the repeater, then we'll go to the switch. Already I told repeater, repeat the signal again. So then you can send your packet to the longer distances. Okay. Sometimes people use hub as a repeater, or there is a repeater device is also there. So your weak signal becomes strong signal, means actual signal after repeater. Maybe I am not sure that is how many people are using these repeaters nowadays. Okay. So I can give an example for easy to understand, because what we are using is Wi-Fi extenders. Wi-Fi extenders. You are in a room, in your hall, Wi-Fi router is there. Okay. So this covers certain distance in your hall and one room. But your laptop or mobile phone is not in the range. You're just outside of its range, your Wi-Fi range. So what you will do? So better to place a Wi-Fi extender which is inside of your Wi-Fi range, and this your device must be in this range only. Okay. So what happened? So this Wi-Fi extender receive a signal and forward the signal to our device. So you are actually not connecting or authenticating through this Wi-Fi extender. You are connecting to original Wi-Fi router only. This is just like a passing mode. buffering 1. It is what? Wi-Fi extender. So it is like in a wireless network, it is kind of repeater. Understand, guys, what is repeater?
Yes, sir.
Again, switch. We have seen hub. This is how hubs look like. With generally hubs are with a small ports because it is suitable for small network. But switches are suitable for both small and large sizes of network. Means more number of devices. Large size of network means more number of devices. Okay. Switches also used for LAN communication. Switch understand MAC addresses and learn the MAC addresses of connected device. Okay. And switch uses MAC address table to communicate between the devices. So that is about a switch. And it is layer 2 in OSA model. So already it said layer 1 physical layer. Example is hardware example is hub. In OSA model, layer 2 is your data link layer. Okay. Data link layer, which is example is switch. Why it is and all we'll see in OSA model. Okay. So your switch initially broadcast. Switch is actually broadcast means send packet to every device like hub only. Okay. And switch verifies MAC address table against the destination MAC address, which is mapped to switch port number. If it is find packet sent to the port, that means it is unicast. So how it is works? Actually, we'll see that. Okay. Same kind of picture. See it is. This is a switch and our devices are connected to a switch. Okay. Think like this. This is the port number 1, switch port number 1, switch port 2, switch port 3, switch port 4, switch port 5, switch port 6. 6 is empty, nothing is there. This is fourth port. Okay. Now A want to send a packet to B. A to B communication. So there is a MAC address table. There is a MAC address table in the switch. In the switch. So what is this MAC address table contain? Contain switch port number and MAC address. Okay, this is the table content. We'll see. Now, A sending packet. So packet will send to the first port number 1. Okay, it is sending packet to port number 1. Then what is this switch will do it? So for port number 1, port number is 1. And what is this ACE MAC? You can recognize ACE MAC address. When packet is came to port number 1, immediately switch will check it, the packet, and the packet contains ACE device MAC address. You check the MAC address, okay, and it will map like this. Port number 1, incoming packet is ACE packet contains ACE MAC address. So it is A device is connected. So it's ACE MAC address. It will put it in this MAC address table. Okay. Next. It will search what is the destination. The destination is B's. And it search for the B's MAC address in this table. It search for the B's MAC address in this table. B's MAC address is not found. Right now it is not found because not written here. Okay. So what it will do? It send that packet to everyone. Just like a hub, it is send packet to everyone. But before it is sending, it check the MAC address table. If it is found, then it will send to this destination. Otherwise, it broadcasts to everyone. So B is accept the packet, C drop the packet, E drop the packet, D drop the packet. Okay. So like this. So another example. C want to send packet to D. Then C send a packet C to D communication. C to D communication. The packet came to the port number 3 where it is connected. Then what it will do? Port number 3. This MAC address. Okay. So in MAC address table, immediately switch what it will take in a 3. So check like 3 incoming packet is from CPC. I think I done mistake. Okay, it will take CPC MAC address and map it to the port number 3. Again, what is the destination? D is a destination. It check the D's MAC address here, not found. Then again it will be broadcasted. Again packet is going to broadcast. Another example, because third example I will conclude. Okay, another example. For example, it's a B2C communication. B2C communication. Packet is sent to the port number, which port number is 2, and our switch will create a MAC address table here. Okay, inside a MAC address table, it will note down port number 2, B's MAC address, because from incoming packet. It will learn the MAC addresses of connected devices. It learn the MAC address of connected devices. Then it check what is the destination. C. It check the MAC address table. Where is the C? And what's the port? Port number 3. So it will immediately send to the port number 3 from port number 3 to C. So it won't send to everyone. Okay. Like this, whenever the devices are first time it is communicating. First time, when it is first time it is communicating, immediately switch take its MAC address. Okay. And which port the device is connected, it put that one into a MAC address table. So initially it is kind of broadcast only, but later it is become unicast. Unicast means I am sending to the exact destination, not to everyone. Okay. So that's one of the reason we are able to use it for larger networks, because no broadcasting means no unnecessary packets are generating. Okay. Another one is securing. Securing means we know the destination, always will send to the destination, not to everyone. Even initially it may be, but now it is not like. Okay. So this is about a MAC address table, how it is created when devices are communicating each other. The switch will take their connected devices at port and as well as MAC address of the connected device. It put it into the MAC address table. Using MAC address table, it unicasts the packets. Okay. So A send a packet to switch. Switch does not know where is B. Switch broadcast packet to every device like a hub. Switch learn MAC address of A and maps A's MAC address to port number 1 in a MAC address table. Like while other devices communicating each other, the switch learns their MAC address, okay, learns their MAC address of the device, map to connect it to port numbers. For example, MAC address is created like this. Now we want to send a packet to C and check the C's MAC address table. Check the MAC address table. Where is C's MAC address? C's MAC address. The port number is 7. It's sent to the port number 7, and it is going to be received to the C's device. Okay. So it increases number of collisions will be reduces. Packet data loss will be less. Okay. So it's work with floating and unicast. There's a cut through and store and forward switches. L3 switches also there. L3 switches mainly used for a inter VLAN routing. Just it's work like a LAN router, but used for only inter VLAN routing purpose. Okay. Just taking a one switch. So I'm connecting to their switch ports. Of course, I'm assigning some IP address here. Assigning IP address to real desktop is different. Here it is different. It's a simulation. Okay. So this is the switch. This is how the switches look like. See, number of ports, totally 24 port plus 2 gigabit Ethernet port, all are 100 Mbps ports only. This is CLI, command line interface to interact with your switch or router kind of stuff. Okay. The Cisco manageable sys, that's why you can able to enter. Normally, in our offices, we are switching, we are using for LAN communication. That is non-manageable. We can't interact with your switches. But here we can do it. in this image. So MAC address table. See, in this MAC address table, nothing is there right now. So we'll see, try to communicate between the devices. Okay, so I've take a simulation and take a packet from here to here. Okay, source and destination IP. Next, packet sent to the switch. But switch check this MAC address against the MAC address table. Not found, it broadcasts to everyone. So finally, the device is received the packet. It send the packet to the destination, means it's replying, sending and receiving. Okay. Again, we will see, there is a MAC addresses are added. We are still running the MAC address. See, finally it is received. So first time it is sent, when it is returning, it is not broadcasting anything. So why? Because of when it is packet is receiving sign, it check the MAC address table, check the MAC address table. So then it send the packet to. Okay. So if you go clearly, what is this port number 4 and what is their MAC address, connected device MAC address, you can get it. Okay. Like all devices are communicating each other. For example, all devices are communicating each other. Okay. Successful. Once again, we will see more MAC addresses. Means when devices are communicating, switch learn their connected device MAC address and map it to its port number. So it uses that to communicate next time, means for unicasting purpose and security purposes. This is switch. Again, hub and switches. Hub, non-intelligent, does not understand MAC or IP address. But switches can understand MAC address and learn the MAC address of connected devices while they are communicating. It maps the MAC addresses to the switch port number in the MAC address table. Switch uses that MAC address table to do unicast. So whenever it is packets are sent, so switch try to understand destination MAC address and check against to the MAC address table. If it is found, it will forward that packet to that switch. Otherwise, it will broadcast the packet. Switch and hubs both are used in LAN communication. Switch is small network. Hub is small network. Switch is small and large networks also. Mainly used for LAN communication only. Switches generally layer 2 only. Okay, layer 2 are general switches. Okay, layer 1 switch means hub. Layer 2 switch means switch only. Layer 3 switches also there. Actually, routers are layer 3 routers, but generally comes under layer 3. But what is this? Layer 3 switches, it is function difference are there, like inter VLAN routing, BTP configurations purpose. Use this 3 switches. Okay. The L3 switches not used for WAN connectivity, but it is for inter-VLAN routing. Guys, understand what is the switch? Key points of switch. What is the switch used for LAN communication? Layer to device data link layer used for large and small and large network. Switch is maintaining MAC address table. It maps connected devices, IP connected devices, MAC address and switch port where it is connected and how it is works. Mhm. And there is a router and there is another one is your modem. Nothing, no response. Yeah. The next one is router. So what is router? Router is a internetworking device. It's used to connect different networks. It is used to connect different networks. Okay. Router we can use in both LAN communication as well as WAN communications. LAN communication and as well as WAN communication. In a OSA model, so layer 3 device is a network layer. The example of network layer hardware device is router. Okay. So these routers are send your packets over WAN networks. Okay. So this is, for example, Hyderabad office, Pune office, New Jersey office. Different places means different geographical location means you have to communicate through WAN connectivity. So this is through WAN, it is connected to here, through WAN, it is connected here, through WAN, it is connected here. So this PC you want to make it communicated to this PC means you have to travel through these routers only. Okay. So from here to here, you want to reach it. These routers will tell you how to reach the destination. That's what we call it as a routing path. The router shows best path to reach the destination. Route means path. The router shows best path to reach the destination. We are here and you are accessing google.com, facebook.com, youtube.com. They are located in different locations. But how you know how you are reaching to the destination? So in between you and the destination, there is several routers. What is they do it? They will tell the best path to reach the destination. Depends upon the bandwidth, depends upon the number of stops like a hop count and uh, okay, link status kind of stuff. Then how these routers will tell you how to reach the destination? Because these routers having a routing table inside. This routing tables is actually for to reach the specific destination, how to go. To reach the specific destination network, how to reach it. So which way you have to go, which way you have to go. That information is there inside these routing tables. These routing tables, we can create static way, means manually can create it, or these routing tables automatically created by enabling some dynamic routing protocols. These dynamic routing protocols are RIP, AZRP, YSPF, BGP, like that. Okay. So this is about your router. Anything understand, guys? Purpose of router?
Understood, sir.
Yes, sir.
This is how routers look like. Okay. These are interfaces for LAN connecting. These two are for LAN communication, and these two are for a configuration related one. And these slots are mainly for WAN connectivity purpose. Okay, so I'm turning off the router. I'm inserting one card. It's like this. If you see, it is two port serial high-speed WAN interface. Serial high-speed WAN interface card. Provide. So I'm inserting this for WAN connection. See, so I inserted a WAN interface. Okay, so it is booting. This is one router. Just for our understanding, I am just copying it and pasting it to the other router. So I'm changing the router name to the R1. For example, that's R1 is Hyderabad office, R2 is something like a Pune office. You can take more routers for connecting purpose. So this is automatically came with the WAN interface. Okay. Now I'm connecting them like this Thunder through WAN interface. This symbol if present is WAN connectivity. It's a port names. What I'm doing is I make a connectivity to this network to this router. So this network actually, it is their IP address if you see. So this net. Maybe you have another network. Okay. Here, just for fun. I'm not configuring anything, guys. It will take a lot of time to configure. Simple to show your diagram. Actually, that picture is enough. What is I showed. Okay. So this is entirely one network. This is entirely another network. So from here, this is one your LAN network. This is another LAN network. Now you want to make a communication from this PC to this PC. How it will do? The packet has to send here to in this router, in this interface. So that interface what we are calling as default gateway, default gateway. And the packet here at router verifies what is the destination. This is the destination network. To reach the destination network, the packet has to send to this direction or any other direction. So it will check in this routing table. So it find destination is this one. So it send here and it verifies where is this network. It is connected locally. It send a packet to here. Okay. Like for example, there is another network. There is another network. Okay. It's connected here to another router. Okay. You want to reach here again. Same cost. Coming to this point from here. Okay. So router will shows the best path to reach the destination. So what is meant by route? Route means path. Path means, okay, what is router do? To show best path to reach destination, it contains routing tables. With the help of routing tables, it will be able to tell the how to reach the destination. Okay. So these routing tables, you can enter manually by going to each and every router. I can configure, but it takes time and you feel everything is something new. When you are not speaking anything, for me, no problem. Okay, for configuration. Okay, so but it is wasting you both time. So, so routing tables are created by manually and it is called a static routing, means manually are entering the routing information. Automatically by using some routing, dynamic routing protocols, these routing tables automatically creates. Okay, understand guys about router?
Sir.
The
Yes, sir.
difference between switch and route. Yeah, tell me. The difference between switch and router. Switch is used for LAN communication. Router is used for both LAN and WAN communication. Both LAN and WAN communication. Okay. So switch is layer 2 device. Is layer 3 device anyway. Okay. So router having routing to make a communication to the destination. Switch use MAC address table to send packets in a unicast way to the destination. Okay. And switch works with MAC address. Router works with the IP address, mainly logical address. Okay. So these are the some of the differences. Modem. So modulator, demodulator. So you know FM radio, AM radio, high frequency decisions, 104 megahertz, 93.8 FM. So what is this? These are a high frequency signals. So whatever our voice is mixed in this frequency, high frequency and transmitted. And we demodulate and send it. So now demodulate and receive it. Okay, guys, in our regular logical, in our network, okay, in our network, whether it is wired or wireless type of network, the signals are generally digital form of signals, 0 and 0 1 type of signals. Okay, these signals we can't able to send for longer distance directly. Okay, that too multiple connectivities, multiple signals are there. We can't able to multiplex it also. So what we are using is, we are using a modem to convert all these signals into some analog format, in high frequency signals, send to the ISP. Okay, so simple to understand, modem is make you to connect to ISP using telephone cable or fiber optic cable. So then you can able to access internet through ISP. Okay, so outside is like, inside of your home is a regular Wi-Fi network only. But from your Wi-Fi to outside connectivity is a fiber optical cable. So internally is Wi-Fi. So different form of connectivity inside. But when you are communicating outside, it's a fiber optical way. So where it is balance between them, modem. Modem is between your two different types of network. So you can understand like that also. So modem make you to connect to ISP. Modem is make you to connect to internet via ISP. Okay. So in most of the cases, we have our Wi-Fi routers, which contains modem, router, switch functionality also there. So this is about your networking devices. Okay. After the break, we'll see about IP address and difference between IPv4 and IPv6s. Okay. And other things also we'll see. Okay. Take a break, guys. Take a some 15 minutes of break. So come back at have some tea or coffee, become energy. We'll get energy. Come back at 4:10.